All right, here we go. Essential question, boys and girls. How do you add, subtract, multiply, and or divide functions? So we're talking about the four main operations of functions. Oh, before I even kind of get started, let me make sure I highlight the key thing for you to make sure that you're cool with this. Watch. Functions. Oh yeah, the first three letters. You talk about a section that's going to be fun. Seriously. You're not going to have anything better than this. Functions. Okay, here we go. Just a couple definitions to get us back on track. A function, by definition, is a relation in which each input has exactly one output. And we talked about this many different ways in class. We talked about mapping diagrams like this right here. We talked about graphs like this right here. We talked about tables. We talked about T-charts. We talked about ordered pairs. But just two quick examples to make sure you remember. A function is when you take one input and you map it with one output. You can't go to two different places. You can't go to three different places. You can only go to one. So, for example, 2 is being mapped to 6, and whatever rule this is in here, the arrow, that's the actual function that's making it map to that. So 2 is getting mapped to 6, and 3, you notice, is getting mapped to 7, and at the same time it's getting mapped to 8. That was a problem we talked about because, remember, new is not a function. Remember my example, I said when you wake up in the morning and you come to school, you only can come to one school. You can't go to two different schools. You can't go to three different schools. On the weekend, your buddies ask you, hey, can you go to the movies and can you go out to eat? Well, you can't go two places at once. You can't. You can only choose one. That's what a function is. If this is you, number 3, it should be number 1, I'm sorry, but whatever. If this is you, you cannot go two places. So that's why it's not a function. However, this over here is good. 1's being mapped to 5, 2's being mapped to 5, 3's going to 6, 4's going to 7. This example here with 1 and 2, it's like everybody in this school. Everybody comes from a different place, a different house, a different section of town, but we all come together at the same spot. That's still okay, because each person is being mapped to one output. Each input is being mapped to one output. So that was a function. So, we also talked about this, I think called a vertical line test. The vertical line test, remember, said, hey, you can draw a vertical line down through any part of this graph. Notice that was a parabola that I had drawn, graph of a parabola. Or actually the graph of a quadratic equation, which is a parabola. So this thing right here, all these lines, no matter how many you draw, if it only intersects the graph at one spot, it's a function. This over here, no good. Boo-hoo. Because it intersects the graph at two places. And then we talked about this, just to remember, function notation is written just like this right here. This is the actual rule. This is red, remember it's f of x. So really it is the value of this function when x is bleh. So the example I have right here is if you have x is 2, down here x is 2, then the actual value of the function when x is 2 is 13. So when you put 2 into this function machine, it outputs a 13. When you put a 2 here for the mapping diagram, it would actually map it over here to 13. So if I did a mapping diagram real quick where this was 2, it would map it to 13. Bam. It's exactly what it would look like. If you did an XY table, you would have X is 2, 1, 2, and Y would be 13 somewhere up there. Whatever. So that's what it's doing. It's a function. It's mapping an input and saying, I'm going to do something with it and map it to one exact output. So that's that. Let's rock and roll. Let's go to the next one. So I want you to write these 3 functions down because we're going to use them throughout these next couple slides. So the first one is f of x. This f function is x squared plus 3x minus 2. G of x is 5x plus 6. And h of x is x minus 4. So those 3 I want you to use. So here's the first operation we're going to talk about. It's called adding. Well, here's my 2 things I'm going to tell you when you do adding of functions. It's probably the simplest one, to be honest with you. But you put parentheses around each function, and then you just simply combine like terms. That's all you do. So if I take this f of x function and I add it to g of x function, all I'm going to do is take in this function right here, put parentheses around it like I did there, and then take this g of x function, put parentheses around it like right there, and then just combine like terms. So you see I have a 3x and a 5x, combine those together to get 8x, a negative 2 and a 6, combine those together to get 4, there's nothing else like x squared, and bam, there is your answer. Notice it is written in standard form. So that's cool. That's exactly it. Second example, g of x plus h of x. Well, if you take these two functions, g of x, h of x, put parentheses around that, put parentheses around that, and then just simply combine like terms. Phenomenal. So you take the 5x and 6x, or sorry, the 5x and the x, and you get 6x, and the 6 and the -4, add them together, and you get positive 2. That's all you need to do when you're adding functions. It's as simple as that. Now, when we're subtracting, you got to be careful with it just a little bit. So, when you subtract these guys, here you go. Put parentheses around each function, just like we did when we just added them. But the key thing, and you notice I circled it and started, you must distribute the subtraction sign through the actual function. And then, of course, you just combine like terms. So my two examples. G of x, remember, was 5x minus 6. H of x was x minus 4. I put parentheses around it, and then that subtraction symbol right there, I have to distribute it through the entire parentheses, as we've seen many times. So that means this subtraction here goes to x, so it's negative x. This subtraction goes here to negative, makes it positive, or an addition, whatever. And this subtraction then changes to an addition. So that gets distributed through there. Key thing is, sometimes students will think, well, when I distribute that subtraction through there, this addition is gone. No, it's not. Like, they think that there's nothing there, so then they multiply. No, you're subtracting. That's the operation. And remember, subtraction is the same thing as adding the opposite. Adding the opposite. So subtract is the same thing as adding the opposite of these numbers, or the operations, signs, whatever. So there you go. So as soon as you do that, phenomenal. Just combine your like terms. So 5x and negative x gives you 4x. And the negative 6 and the 4 give you a negative 2. That's it. So over here, h of x and f of x, you see I take the subtraction symbol. And since subtraction is the same thing as adding the opposite, it's the same as adding the opposite of all three of these things. So this subtraction, negative sign, goes to the x squared, makes it negative x squared. The subtraction goes to the 3x, so it's a subtraction over 3x. And this subtraction symbol goes over here and changes that to plus. And there you go. So as soon as you get that, that's the key thing. That's why it's starred right here. Distribute through the entire parentheses. And then combine your like terms. There's nothing like this, but there are 3x, negative 3x, sorry, and an x. That goes to negative 2x. And negative 4 and positive 2. Negative 4 and positive 2 goes to a negative 2. And you're done. So subtraction's very similar to addition. You just got to make sure you distribute the subtraction symbol through there. That's it. Let's go on to multiply. Multiplying functions. Well, when you multiply functions, same thing applies. I would make sure I put parentheses around each function. Just kind of sets the stage for everything. And then you're going to, oh, here's a word, distribute each term in the first polynomial to each term in the second polynomial. Now, I'm going to actually look at example 6 first because it'll help you understand what you're doing. You'll remember this. Remember when we talked about, oh, well, this is a weird one. Look at it. H of x times h of x. We're taking the function times itself. Interesting. Well, if you look, here's what I've done. I put parentheses around this. Now, wait, we've seen this before. A binomial times a binomial. Well, I know what you might be thinking, but let's follow what this says. Distribute each term in the first polynomial to each in the second. So that means we take this x, and we distribute to this one right here. And then we distribute it again to that one. So we're distributing this term in the first polynomial to each of the terms in the second polynomial. And by the way, x times x gives me x squared. X times negative 4 gives me negative 4x. And then I go back and do the same thing. Distribute each term in the first. Well, I haven't done this one yet. So I got to take the negative 4 and distribute here, which gives me negative 4x. And take it again, negative 4 times negative 4, which gives me positive 16. So when I combine my like terms, I get negative 8x, and there is my answer. Now some of you are looking at this and saying, hey, I know that. And you should, because this is the same thing as the FOIL method. Bam. Remember, so it's for first, outers, inners, and last. That's exactly what we talked about. Now the reason I started with this is because it's the same concept, except you only really FOIL with binomials when you're multiplying. So binomial times binomial, that's really FOIL. Over here, you're not FOILing it, because you're not taking first, outers, inners, last. You're doing more to it. But it's the same concept. You take this 5x, and it gets distributed to the x squared. So that's why you get 5x to the third. Take the 5x and distribute it to the 3x. So 5x and 3x gives you 15x squared. And then distribute it to there. So you're not FOILing, you're distributing that first term to all of the ones in the second polynomial. And then you do the same exact thing with the 6. Distribute it here, which gives you 6x squared. distribute the 6 to that, which gives you 18x, and distribute the 6 to that, which gives you negative 12. Phenomenal. So that means now, if you notice how I did this, I actually stacked them. It's a method I call, it's called stacking them, where you put the actual like terms in columns. So there's nothing like 5x to the third, so now it's pretty simple because I just add down the columns and I get 5x to the third. These guys give me 21x squared. This actually gives me 8x, and that gives me a negative 12. And that's it. There's my answer. Perfectly done. So put parentheses around it, distribute each term, kind of like FOIL, but be careful because you're not foiling here, and then combine your like terms. Sweet. Last one. We got divide. Let's talk about division. Well, when you divide functions, there's many things that you can do with it, and as I put down here, I look forward. You should be looking forward to this because we're going to be talking about a lot of different things that you can do when you're dividing functions, but in this particular section, really, this is all you need to do because there isn't going to be too many difficult ones yet. So you're going to take the functions, whatever they are. Notice I don't have anything really written here. It's because all you do is you take the function and rewrite it, the g of x, rewrite it, and it's division. See the division bar. So you just simply keep it pretty much like that. Now, you can simplify some things at certain points. That's what we're going to get to later. There's nothing that you can really do with this. You can't take this 6 and the negative 2 and cross them off because of this subtraction, addition, and addition. You can't do it. They're not factors. They're not being multiplied. So you can't do that. You can't reduce it that way. That's improper simplification. So, improper reduction, whatever you want to call it. So that one right there actually stays exactly the same. Down here, h of x is x minus 4, g of x is this, and that really would be your final answer. There's nothing else you can do. You can't factor anything. There's no factors there, so you cannot take the 4 and the 6 and do it, meaning simplify it, reduce it, and you can't take the x and the 5x, you can't do it. Can't. But I am going to show an example where you can do some simplification. So over here, forget the f of x and g of x. I've made new functions now. So let's say f of x is 2x to the 7th, and g of x is 6x to the 3rd. Well, if I ask you to divide those two functions, I would just simply take this 2x to the 7th, plug it in for f of x right there. I'd take the 6x to the 3rd, plug it in for g of x right there. So this is now what I'm looking at. Well, you can't just leave it like that because notice I don't have any additions. I don't have any subtractions. I actually have factors. It's 2 times x to the 7th. I have 6 times x to the 3rd. So I can break those up into two smaller little problems. So I could take 2 6 and reduce that by 2 to get 1/3. Sweet. So I get 1/3. Sorry, I mean 1/3. So I get 1/3 over here, x to the 7th divided by x to the 3rd. Oh wait, I'm dividing powers that have the same base. And remember the rule? Do you remember? You should. You subtract the exponents. So same bases, dividing powers. So you subtract the exponents, and that would give you 7 minus 3, which gives you 4. And then you just kind of put those things back together. So that gives you 1/3 x to the 4th. You just kind of glue them back together. And that would be your answer. So when you're dividing, sometimes you can simplify these things down a little bit further. Matter of fact, you could rewrite this a little bit better too. If you wanted to, you could do x to the 4th over 3. Both of those are the same answer. Either one's totally fine. So there's divide. Now, here's what I want you to do. I'm going to give you two completely different functions. Another f of x function, a completely different one than what we've seen so far, and g of x. And I'm going to give you these 3 things to do. And I'm going to stop the video. I want you to do these questions, and in the next video, we'll explain the answers, and you'll see how you did. So all you're doing is taking the f of x and dividing it by g of x. So this function divided by this function. And then I switch them. Boop. So now you're doing g of x, this one, divided by that one. And then I'm switching it up on you just a little bit, tricking you. I want you to multiply f of x times f of x. So you're taking this one times itself. So good luck. Give it a whirl. Go back and watch what you need to watch to be able to do these, and watch the next video to get your answers.